So, today we're going to talk about, well, this unit begins with the Pythagorean theorem and the special right triangle. It matches up with 8.1 and 8.2 in the book. Hoping that by the end of the week, you can utilize the Pythagorean theorem as converse to problem solve, and then develop and utilize the 45, 45, 90, 30, 60, 90 right triangles to find missing links in problem solve. To start with, what is the Pythagorean theorem? Okay, well, you probably know it visually like that, where C is the hypotenuse and A and B are the legs. So the sum of the squares of the legs, meaning A and B, of a right triangle is equal to the square of its hypotenuse. Alright? So if we're looking at a right triangle in feet, as the one on the left is 20 feet and 21 feet, 21 squared plus 20 squared equals x squared. Alright, so they're giving us the two legs. So I square both of those numbers and add them. 21 squared is 441. 20 squared is 400. I add them together to get 841 equals x squared. And then I do the square root. I get 29. Alright, with the next one, we'll show you how to do the square root and all that. So there's the 29. So when I do the next one, alright, hypotenuse is given, so 10 squared plus b squared equals 26 squared. 10 squared, hopefully all of you know, is 100. 26 squared is 676. Alright, so I come here, to get rid of the plus 100, I would subtract it. So b squared equals 576. Now we're going to do the square root. Well, I go to my calculator and do the square root. I can do it two ways. Number one, I can hit second and the x squared button. Alright, notice in blue it has the square root. So if I do second square root, and I put in the number, 576, it'll shoot out, it'll shoot out my answer. I gotta do that again. So you hit second and then the squared button. And then you enter the 576. No. And it'll give me the 24. The other way, and you'll learn this in algebra 2, is what's called rational exponents. The square root is the same thing as the exponent 1/2. So you can use the exponent button and do 1/2 or 0.5 and you still get the same answer, 24. So my final answer B is 24. Alright, well let's do some analysis. What did the two problems have in common? Both problems involve integers, because they involve what we call triples. Alright, so that'd be 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, 17. Those are the common ones. Alright, there are others like the one we just did over here. 20, 21, 29. Alright, there's 9, 40, 41. Alright, if your answers are integers, then they are the result of either a triple or a multiple of a triple. Alright? What I mean by that is this. If we go back to this one, 10 is 5 times 2. 26 is 13 times 2. Alright, well you'll notice 5 and 13 make up two parts of a triple. 5, 12, 13. So that's why this one could be 12 by 2. Again, you don't need to know the triples, they just make your life a whole lot easier when you do it. Alright, now how do the two problems differ? Alright, well, for one problem we added, and for the second problem we subtracted. Alright, that is because it depends on what they asked for. If they asked for the hypotenuse like they did in the first one, alright, then we can add our values. Whenever we get the leg, we subtract. Now, if you want to use the triples, here's the idea. 12 is 3 times 4. 16 is 4 times 4. All right, you'll notice here 3, 4. You go to your triples and you see 3, 4, and 5, which are part of it. Okay, well, that means that side would be 5 times 4, which is 20. All right. Now again, you can feel free to use regular Pythagorean theorem and you'll get the same answer. 12 squared is 144, 16 squared is 256. Add them up, you get 400, and making C the square root of 400, which is 20. All right? So again, they're great. The triples are great to help for time consuming. However, they're not mandatory. But only if only life didn't throw us curves. So now we got one with 8 and 20. So 8 squared plus 20 squared equals C squared. 8 squared is 64. 20 squared is 400. 64 plus 400 equals C squared. 464 equals C squared. You go to your calculator. Second squared, 464. Dang numbit, gives me a decimal, 21.54. We don't want to do that. We've moved past that in life. So what we want to do is we want to simplify radicals as we practiced in class previously. So 464 equals C. When you have an irrational number, all right, an irrational number is a square root that doesn't come out to be a perfect square. The first factor you should look for when simplifying, which we're going to do for a second, is the GCF, or greatest common factor, of the values of the two sides given. So in other words, if I look at 8, 8 is 4 times 2, 20 is 4 times 5. 4 goes into both. All right, so I know 4 is going to be part of my answer when we're done on the outside. Well, I take 4 squared, which is 16, and I divide it. And I get 29. Again, you can use the method we discussed in class, which is using the graphing calculator. Feel free. But again, we talked about it yesterday. Square root of 464 is the square root of 16 times 29. Square root of 16 is 4, so that simplifies down to 4 root 29. And that's what we're going to get. Now, the second part of this first one, and I don't know how much of this you did last year, is the converse. If a squared plus b squared equals c squared, then the triangle must be a right triangle. All right. So now I'm looking at 13, 85, and 84. Now, the first thing you got to identify is your biggest number. All right, that's got to be the hypotenuse if it's a right triangle. So that'd be 13 squared plus 84 squared. And I'm going to put the phrase versus 85 squared because I don't know if it's equal yet. 13 squared is 169. 84 squared is 7,056. 85 squared is 7,225. So now I add 7,056 to 169, I get 7,225. And you'll notice the two values are exactly the same. As a result, yes, we can conclude that those are the sides of a right triangle. Now, what we want to do is use it beyond right triangles, because not every triangle is right. All right, so here's the right triangle with 5 and 13. If we use triples, it's 12. If we make the right angle acute by making it smaller, 5 stays the same, 12 makes the same. But the opposite side gets smaller, so that's less than 13. If we make the angle obtuse bigger than a right angle, you'll notice once again the 5 and 12 stay the same, but now instead of less than 13, it's bigger than 13. Well, that enables us to draw conclusions. If a squared plus b squared is greater than c squared, then the triangle is acute. If a squared plus b squared is less than c squared, then the triangle is obtuse. So if I'm looking at 7, 8, 9, again, first thing we identify is the 9. So I got 7 squared plus 8 squared versus 9 squared. 7 squared is 49, 8 squared is 64, 9 squared is 81. 49 plus 64 is 113. And we realize 113 is greater than 81. Whenever that sign is greater than for the inequality, we know it is acute. Now when I look at the 5, 10, and 14, again, two smaller ones go over there. 5 squared plus 10 squared versus 14 squared. 5 squared is 25, 10 squared is 100, 14 squared is 196. I compare 25 plus 100, which is 125, to 196, and I realize 196 is greater than 125, therefore that would be obtuse. A brief note, we'll deal with this later in the year when we have triangle inequalities, but 5, 10, 15 cannot be a triangle. Alright, you're not going to be responsible for that just yet, but the two sides, 5 plus 10, has to be greater than the third side, 15. Alright? The last thing we're going to talk about in this lesson, distance formula, an extension of Pythagorean theorem. First, the formula itself. The distance between 2 points A, x1, y1, and B, x2, y2 is distance equals x1 minus x2 squared plus y1 minus y2 squared. Alright? If you like formulas and you can keep all the subscripts clear and the minuses and the pluses, feel free to use that. So you would plug in the coordinates for the points, carry out the operations, and simplify the radical if necessary. Or, and this is how I do it, draw the corresponding right triangle out, and then use Pythagorean theorem to do the exact same process. So here's what we got. Let's say we got point A, 3, 8, point B, negative 1, 20. Alright. So if we want to use the distance formula, we got all this punctuation we got to worry about. Alright, so it's subtraction between the coordinates and addition outside the coordinates. Alright, so that could be the 3, that would be the negative 1. They could also be switched, but that's squared. Now I look at the y's, that would be 8, that would be 20, again that's squared. Again, order is not going to matter. 3 minus negative 1 turns into 3 plus 1, which is 4. 4 squared is 16. 8 minus 20 is negative 12. Negative 12 squared is 144. And together I get the square root of 160, which breaks down into 16 and 10. Why 16 and 10? Because 16 is a perfect square. And that gives me 4 root 10. Alright, so that's using the formula. Now, if you want to, like we said, we can draw the right triangle out and plot the points. So again, A was at 3, 8. So that's up here. B's at negative 120, so that might be up there. It doesn't have to be drawn perfectly. Alright, but it's enough to give us the guidance. So we're trying to find that distance right there. So this is what we mean by turning it into a right triangle. Kind of like we did with midpoint and working backwards. For our x-coordinates, we have negative 1 and 3. Well, from negative 1 to 3 is 4. And then we're going from 20 down to 8 or 8 up to 20. Either way, you get 12. So now we can use Pythagorean theorem. 4 squared plus 12 squared equals c squared. 4 squared is 16. 12 squared is 144. Add them together, I get to 160. I do the square root. I get the square root of 160. And then once I'm done simplifying, I get, oh, what a surprise, 4 root 10. You'll notice how a lot of the steps end up with the exact same math. Alright? Okay? So there's a lot of parallels between the two methods. So you can pick either one. It's completely up to you what you want to do. Alright? I hope this helps. Be safe. Be healthy. Talk to you soon. Bye.